The first question that we are attempting is finding the binary tree maximum path sum. This is listed as a hard problem, but in my opinion, this is not hard. This is like a medium question that we can do. So we'll look into it. What the question says. The question talks about that given a binary tree, we need to find out the maximum path sum. Like for example, the path is defined as the path between any two nodes. So like 15 and 9, the path is like 9 minus 10, 20, and 15. So you can take any path in the tree and you have to return like the sum on any maximum given path. That's the intent of the problem. It doesn't have to pass through the root, it can pass through any node in the tree. The elements in the tree can be negative and positive, both. So this is the question. And any constraints given in this problem? No, nothing. And this problem has been asked very frequently in most of the good. We'll be finding out couple of things for every given node. That first, what is the maximum path sum coming from its left hand side? Then what is the maximum path sum coming from its right hand side? These are the two things we need to know. And then what is the maximum path sum including that given node itself? So if you look at it, let's take a little complex example. I think this is still okay. So in this question, 15, 20, and 7 is the maximum path sum, right? Because if you to take any other path like 9 minus 10, 20, and 15, so 9 plus minus 10 is minus 1. And if you add minus 1 to 20 and 15, this is lesser than adding 7 to it. So 15 plus 20 plus 7 is the maximum sum over here. But couple of things to note down, that the values in the tree could be negative as well. Like instead of 9, 15, and 7, it could have been the negative values like minus 9, minus 15, minus 7. In that case, your maximum path sum would be just 20, just a single node. So those are edge cases. If someone asks you about the edge cases, you should be able to talk about these edge cases. And it can possibly happen that, so essentially a single node can also be the answer to the maximum path sum. It doesn't have to involve multiple nodes always. You have to calculate the maximum path sum at every given node during a recursive program. And then we need to keep registering this maximum path sum every time we are visiting this any node. We need to keep a track of the maximum path sum found so far. The second thing is, the recursive program is not going to return the maximum path sum to its upper node, like to the caller function. Instead, it is going to return the maximum path from any one of the given node, from any one of the given paths, either the left hand side path or the right hand side path. The reason for that is, when I come at minus 10, all I care about is the maximum sum from the left hand side, maximum sum from the right hand side. But if you notice, what will be the maximum sum from right hand side? It cannot involve all the three nodes, 15, 20, and 7, because if it involves all the three nodes, then minus 10 cannot be included with that. It means that minus 10 is going to care about what is the maximum path sum for 20, coming from either the left branch or from the right branch or just the root itself. So essentially we will be passing 20 plus 15 to minus 10, that this is the maximum sum from the right hand side, which is 35. So what is the maximum sum that node number 20 can propagate up to the parent? So the maximum path sum that node number 20 can propagate upwards, it is just one of the branches including the node number 20. So okay, so we need to take care of that. So for this purpose, what we are going to do is, we are going to have two approaches to solve this problem. So first approach is using the global variable. So this is going to return us the integer, and we'll say that sum approach max path sum, we'll just call it as 1. And here we'll be passing in the root, and then we'll say that if root is null, then we can just simply return 0 in that case. This is our base case. The next thing, after the base case is done, we can compute the maximum path sum for the left hand side and the right hand side. So let's say that I compute the maximum path sum for the left hand side, which is my max path sum 1 root dot left. Then I can compute the max path sum for the right hand side, which is again going to be root dot right. Once it is done, now we know that this is the maximum path sum coming from the left side, this is the maximum path sum coming from the right side. Now we need to do two things. First, we need to update the global maximum path sum that we have found so far, including this root and including this left child and right, left sum and right sum. But we also need to take care of that we do not propagate this maximum path sum to the caller function. We just propagate one of the sums, including the root. So to accomplish that, what we are going to do is, first of all, it's a tricky comparison, because there are lot of if conditions, like if this plus this is lesser than this, then just propagate this. And if this plus, so there are almost like four comparisons. One is just having left plus root, second is right plus root, third is left plus root plus right, and fourth is just including the root. So this part I'm talking about for the for propagating the maximum sum. So to do that, what we can first do is, we can maintain a global variable over here, and we can say that this is the result. Now, which by what value should we initialize this result? We cannot really initialize it with 0, because the values in the tree could be negative. In that case, we have to return the, let's say, whatever is the max possible out of all those negative values. So I'm going to initialize it with the minimum value that we can assume. So minus infinity, basically, we are going to start with, and we're going to optimize things a little bit over here. So now notice that the left side sum could be a negative value and the right side sum could also be a negative value. In that case, I do not even want to add those negative numbers to my uh, to any of the computations. If the left side is negative, right side is negative, there is no benefit of adding these computations in my overall um, maximum path sum. So what I can do is, I can simplify it by saying that if either it is this or it is 0. So if, so basically, if left side sum is negative, then just choose 0 instead of having a negative number. And then similarly, I can do the same thing for my right hand side. So if it is a negative number, then you just choose 0. This is one way of doing it. You can do it in your own approach as well. But I'm doing it to make sure that the number of comparisons we need to do is bare minimum. um, the second thing, we need to update the global result, which is our maximum path we have seen so far. So what we're going to do is, we're going to say that result is going to be math.max. And since I'm finding here the maximum path sum, I'm going to add left plus right plus root. Please note that I'm able to add all of them together rather than making three comparisons, in fact four comparisons. So here, since I have already, in case the left side sum and right side sum were negative, we have already made them to 0. So here we can say that it is going to be a max of result, and then left plus right plus root dot val. So this is like the this way it avoids making unnecessary comparisons and it keeps the thing simple. So this is the first part. We have updated the global max, which is going to be our maximum path sum. Now maximum path sum will involve left side, right side, and the root. Like it can involve everything. But when we have to return to the parent, to the caller function, we don't return all three. We just return either the left plus root or the right plus root. So here what we're gonna do is, we're gonna say that just return the max of left plus root dot val or right plus root dot val. So this is going to be our return value, and that's pretty much it. So we can simply execute this. Yeah. So here we'll just execute this, and we'll see what's the issue. So I think the mistake that we are doing is we don't have to return the value from the max path sum, because it is only going to give us the maximum sum in one of the branches. So that's what it is giving us, right? So with 1 as the root, it is giving us 4, which is the maximum path sum on the branch. So we need to call this, but the answer is being saved into the result. So we need to return the result. I hope this part is clear. But if interviewer asks you that, hey, can we not use global variables, and is there a way to, like, avoid the global variables? So yes, there is a way to do that. What we can do is, we can write another approach where we do not use the global variables at all. Only thing to note down over here is we need to return two values. The first value is the maximum sum along one of the paths, the left path or the right path, that we are already doing. But along with this, we also need to return and maintain a global maximum path found so far. So instead of using a global, we need to pass in a persistent variable which we can modify. So what we can do instead is, instead of returning a single value integer, we could return a int array whose length is 2. So essentially what I'm going to do is, I'm going to add another method over here, which is simply going to return me an array. Inside this array, the size of this array will be 2. So what we can do is the same approach. If root is null, then we can just say return 0. Okay. And then we can just simply copy paste everything, no change in the code. Okay. But please note that instead of a single variable, it is now going to return us an array. That's the only change that happens over here. So it is going to return us an array instead of a single variable. And now we need to again keep track of the left max. So I'm gonna use left max as the same approach, math.max. So we'll say that math.max, and we are going to do a max between 0 and the value present inside the array. So the as we decided, the first value or the 0th index is basically referring to the sum of a given branch, whether the left branch or the right branch. So we decided that 0 is going to refer to the branch, one of the branches, and 1 is going to refer to the overall part. So this is all I'm doing over here. So right max is again in a similar fashion we're gonna do. So right of 0 comma 0. Okay. And now we need to update the result. So result is, okay, what's the result? We need to first of all get the result. So I can just call it as a, since we don't have a result as a global variable, so I'm defining the result as a local variable over here. We can say that this can be the math.max between, okay, now couple of things. We already, this result essentially is the global max that we have seen so far, right? And we are also persisting the global max in the first, in the second, as a part of the second element of the array, in both left and right. Like what's the max the left side has seen so far, what's the max the right side has seen so far. So what I'm going to do is, I'm going to use their, let's say, right one. So this is the maximum that we have found from the left and right. And then we are also going to compute the maximum from the given node itself. So that maximum is nothing but our left max plus right max plus root dot val. So we need to find the max of all these three plus root dot val. And we can put in another max function just to compare the max out of all these three values that we are noticing. I hope this part is clear. So here we are not using a global max variable. So essentially whatever is the max seen by the left side tree, and whatever is the maximum seen by the right side tree, we are taking a maximum out of it. And then we are checking whether that is still the max, or whether the current route that we have, can we find a better value for the global max path or not. So this is going to be our result. Now the second thing is, at the last we need to return back an int array from this function, right? So this int array is going to be is going to have two values in it. The very first value inside this int array is going to be the one of the maximum branch, whether the left branch or the right branch, and the second value is going to be the global max. Global max we have already stored in the result, so we can just pass in the second parameter as a result, and the first parameter that we need to pass, that will be the um, either the left side max or the right side max. So what we're gonna do over here is I'm gonna pass over here root dot val plus left max, comma root dot val plus right max. So this is exactly the same as in the line number 15 also. We were doing it right, so we were returning the one of the branch maximums. That's what we are doing here, root the one of the branch maximums, but we also need to return the second parameter, which is the global max. So this is like in this using this we have eliminated the use of our global variables, and we are returning everything from the recursive function as an int array. The size of this int array is just 2, so it's a constant space. And what we can do over here is uh, we can just instead of this we can just simply say return max path sum to root, and we can run this. There is some compilation errors. Max path sum, let's see what's the issue is. Int cannot be converted to int. So okay, so this is going to return us an integer array. So what we can say is that this is going to return us an integer array, and we need to return the the second element of it. Basically that is going to be a result. There is another issue with that, line number 20. It says that okay, so if root is null, we cannot just simply return like we cannot return 0. If it's a null node, we need to return something a very negative value. The reason is that we are not using here global variables, so we cannot initialize the result. We cannot really initialize the result with let's say the integer minimum value. So this is our opportunity to do that. So what we're going to do, in case if this is the case, we can just simply return an integer array, but we should not be returning 0 comma 0. We should be returning a minimum value over here. At least for the result we should be returning a minimum value, and even for the branch whatever we can return, it doesn't really matter for the branch. So what I'm gonna do is I'm just gonna return integer dot min value for both of the cases. So this is kind of an initialization, we can say. And the reason we are taking a minimum value, because the nodes can simply be just the negative numbers. There is no positive number inside there, so we cannot really initialize it with 0. Integer dot min value, I think there's a typo over here. And line number 22, we need to call the method 2. So I'm just gonna pass in 2 over here, and I think that's it. So let's try to run it. So this works. We can submit it also. So yeah, if you get this problem during the interview, definitely it's a little tricky. It's not very straightforward problem. So you should be able to understand like what are we computing and what are we returning. So we cannot return to the recursive function directly the result. We need to return the maximum sum across just one path, but we also need to capture the maximum sum across including both the paths, the left path and the right path. So that's the main complexity here, and once you are able to understand that part, then the problem becomes really easy. And then there are a few more problems. How do you compare, do the multiple comparisons? And for that we have our logics. So we can simply ignore the left side sum or the right side sum by making it 0 if it is a negative number, basically.